In this video, we're going to be taking a look at Kirchhoff's current and voltage laws and rules, and we're going to be applying them to a couple of problems. So let's start with the first question. We have a cell, we have a resistor, we have a filament lamp. Here's our first loop. In our second loop, we have another resistor, and it connects back. Here the voltage across the cell is 10 volts. And the resistance is 1.0 ohms across this resistor. Across this filament lamp, it's 3.0 ohms. And here it's 0.5 ohms across this resistor. Now, the question is asking, find out the current, let's call it I2, across the 0.5 ohm resistor. So let's call the current from the power supply I1. Therefore, in this middle branch, we can call this current I1 minus I2. Here's our first crucial Kirchhoff law, considering the current. I1 equals I1 minus I2 plus I2. From this junction here, we see that the summation of these two branches equals the original. So now let's get to solving the problem. Let me just make some space. There we go. Starting with loop A, and we'll eventually work our way to loop B. We're going to be starting from the power source, so that's plus 10 volts. Since current is flowing in the same direction as the resistance is, and since we're considering the positive terminal, the movement of positive charge, therefore this movement of electrons is going to be considered negative, minus 1.0 I1. Then similar principle across the filament lamp. In this first loop, we have a minus, and simply just the resistance multiplied by the current. And this is our Kirchhoff voltage law. That summation has to equal 0 in the loop. The voltage rises and falls to 0 overall. Now, to simplify this equation, we can write it as this. Ten equals 4.0 I1 plus 3.0 I2 equals 0. 10 minus. Let me get rid of this. And therefore we can say that 10 equals 4.0 I1 minus 3.0 I2. This will be our first equation that we have to keep, because eventually we'll get another equation from our second loop, loop B. Speaking of loop B, if we apply the same rules and logic, start from this top left hand corner here as we did before and go around in a loop, we have minus 0.5 I2 plus 3.0 times the middle current here, in this case I1 minus I2, And now this is going to be equal to 0. Now we can simplify this second equation here as well. So if we break it down, we'll get this statement. 3.0i1 minus 3.5i2 equals 0. And if we equal them to each other and then divide by 3.0, we'll get I1 being equal to 1.2 I2. Now, our first equation we worked out and our second equation we worked out, we can see that we can substitute I1 over here down below into this first equation. So upon doing that, we'll get a final overall third equation by combining our two simultaneous equations here. And the equation we'll come up with is 10 being equal to 1.8 I2. Divide by 1.8 into two significant figures, I2 will be 5.6 amps. And therefore, we solve the problem. We know what I2 is, and I2 is simply 5.6 amps through this 0.5 ohm resistor. Let's try another problem. Here we have another cell, this time 8 volts. We have a circuit, another resistor. However, this time we have another cell here going down the middle pathway. And in our second loop, we have a resistor over here. And the question is to find the current through this 2 volt resistor. Cell. Now, the given values for resistance are 7.0 ohms and 1.0 ohms respectively for these two resistors. Once again, we'll say that this is I1 from the power supply, the largest power supply in the circuit at least. And we'll start from this junction again, and we'll split it up into I2, and again as I1 minus I2 for the middle one. So essentially what the question is asking is to find the current through this 2 volt battery, and to do that it will just be equal to whatever I1 minus I2 is. Now, let's break it down into loops. And in loop A, our first loop, we can see that we have 8 volts going around, minus 7.0 I1. That's past our first resistor. And since this cell is going from a positive terminal to a negative terminal, we flip the sign, because here, if you remember, we kept the movement of positive charge as positive. However, here is indicating the movement of negative charge. So now, in our equation, that's going to be a minus 2, and all of that will be equal to 0. Before we form our equation for loop B, we can solve for I1 already, and we can say that I1 at 7.0 I1 is equal to 6 volts, and therefore the current is just 6 divided by 7.0, and we'll get a value of 0.86 amps as I1. Now consider loop B, our second loop to the right. We have, well, starting from this junction here, top left hand corner again, we have minus 0.1.0 I2 going through this first resistor over here, plus 2, because this time the movement of charge is going from negative to positive across that 2 volt cell, and all of that will be equal to 0. This tells us that I2 is simply just rearranged, and we can write down that 2.0 amps is just 1.0 I2 divided by 1. We can just say 2 amps equals I2. So with that in mind, we finally have all the components needed to find the current through the middle pathway. Now using Kirchhoff's current law again, we can see that the middle pathway is simply I1 minus I2. So 0.86 minus 2.0 simply equivalent to 1.2 amps. And that's our final answer. This negative symbol also indicates that the current is not actually flowing in this direction, but it actually rather in the opposite direction there. Because when using KCL, Kirchhoff's current law, KVL, Kirchhoff's voltage law, you can just account for the signs afterwards and see which direction current really flows. Thank you for watching the video, and leave a like and subscribe. Have a great day. See you next time.